everyone, welcome to Try Right, the new era of learning. This is Pack 365. In Module 2, we are discussing about A-star algorithm in AI. Let's start the topic. In this topic, we learned about what is an A-star algorithm in AI, components of A-star algorithm, how does A-star algorithm works, and applications of A-star algorithm in AI, and advantages of A-star algorithm in AI, and two disadvantages of A-star algorithm in AI. So let's begin the topic. A-star algorithm in AI. So A-star algorithm is popular and effective algorithm used in artificial intelligence for finding optimal paths in the graph traversal. It efficiently searches for the shortest path between the nodes in the graph by maintaining the cost of to reach each node. Each node represents a specific position in the grid. So, the A-star algorithm is widely used and highly effective pathfinding and graph traversal algorithm in artificial intelligence. It renowned for its ability to find the shortest path between a starting point to and a goal state. So it finds the shortest path between starting point and the goal. Okay, in a graph, while being more efficiency than more other such algorithms. From the so an An AI star algorithm is an example for informed search as it combines the advantages of Dijkstra algorithm, which graduate to the shortest path, and greedy best first search, which uses the heuristic to prioritize nodes likely lead to the goal. It usually heuristic function, often denoted as h of n, the estimates to the cost from a given node to a goal node. So goal that lead to the most optimal path to the desired node. So here the conclusion is right, but so informed search, A star is an informed search algorithm, also known as a best first search. So this means it uses a heuristic function, right? A heuristic function to guide its search. Unlike uninformed search algorithm like breadth first search or depth first search that explores the blindly, but in case of A star, uses an intelligent estimate to prioritize which path to explore, making it much faster in the scenario. So the algorithm maintains two lists, the open list and the closed list. So it evaluates nodes based on the sum of the costs to reach the node from the star denoted as a g of n and a historic element estimate to the goal h of n. The nodes with the lowest total cost f of n equal to g of n plus h of n is selected from the open list. From expansion, the process is continue until the goal node is reached or there are no more nodes to explore. So the core component of and the cost function of f of x. So here we can say f of n. A star works by the evaluating each node, right, in the graph based on the cost function of f of n, which is the sum of the two components, g of n, actual cost, and h of n, heuristic cost. So let's begin with actual cost. This represents the actual cost of the path from the starting node to the current node of n. It's the cumulative cost of all the edges traveled to the reach n. H of n, heuristic cost. This is the estimated CC from the current node n to the goal node. The quality of the heuristic function is the crucial for the algorithm performs. A good heuristic should be assemble and consistent. It should never override the actual cost to the reach to goal node. If they overestimate a star might not be find an optimal shortest path consistent like a stronger considered than the um, admissionable the estimated cost from a node n to a goal, so plus the cost of the moving from n to a neighbor of n should be less than or equal to estimated cost from n to the goal state. So the A star algorithm always select the node with the lowest f of n value from the set node of the explore the next node. So, let's begin with the components. We have the components of the A star algorithm. So we have the algorithm is implemented on the graph consisting of nodes uh, and connected by the edges. Each node represents a state of or a position. So here we have cost function. We have in cost function A star uses two cost functions, right? We have discussed about g of n, h of n. A g of n is the actual cost to reach a node from the start node, and h of n is the heuristic function estimating the cost from the node to the goal. So is a formula. we have considered a formula. The total cost for a node is given by the sum of those two functions, f of n equal to g of n plus h of n. So we have a two list. We know that open and closed list. So the algorithm maintains the two lists, the open list and the closed list. The open list stores the nodes that are candidates for evaluation, and the closed list keeps tracks on the nodes that have already been evaluated, means visited. So here the graph we have this. So this is in a type of part of a star algorithm, a graph. So like this graph, we can assume which from what kind we want to move from like B to E, B to A to B, or B to D. We want to select a goal state and we want to move to the goal state by choosing the lowest path values according to the lowest or equal to the our f of n. So how does A-star algorithm works? So to implement A-star algorithm in code, one must understand how A-star algorithm works in the background, right? So here is step-by-step guidance on the working of A-star algorithm. Let's begin. So in step one, initialization step. So first define the starting node and the goal node within the graph. Second, then create two empty sets. What the sets? Open set for open set and closed set. Open set for stores nodes to be explored, initially containing only the starting node, and stores to explore the nodes. So we're going to maintaining two list and open list for a node to be evaluated, and the closed list for node to the have already been evaluated, like visited and non already visited. And they start the node and the starting node to the open list, setting it has g of n to the 0 and calculate its h of n and initialize the f of n for the starting node to g of n plus h of n. Second, we have step 2. In step 2, it is starting iterating the graph. So while the open set of it's not empty, while the open set is not empty, select the node with the lowest f score from the open set. So this node will be most eligible to the reach the goal. Move the selected node from the open set to the closed set. Expand the current node. Explore all its neighbors and their connections. For each neighbor, calculate g of n and h of n, and then calculate the f score for the starting node and using the formula of f of n to g of n equal to h of n, right? So here what we can select here a loop, like we have a loop here. So while the open list is not empty, select the node with the lowest f of n value from the open list. Let's call this the current node. If the current node is the goal node, a path has been found. Reconstructed the path by backtracking from the goal node to the start node using the parent pointers. Okay. So move current nodes from the open list to the closed list. So initializing, we have the steps. Initializing score that of the starting node, and if g of n has the g score of the starting node, always zero from the starting node, and a of h of n is a heuristic estimate of the cost reached to the goal node from the starting node. So A star algorithm iterates to continue. Wait a second. So here we have if the neighbors is not in the closest set, in the case of A star, it iterates for the whole graph by following the steps. So if the neighbor is not in the closest set, we cannot consider. If the neighbor is not in an open set, add within the F score. If the neighbor is already in the open set, update the neighbor's G score and the F score. If the new ones are already lower, if the neighbor is the goal node, like reconstruct and return to the shortest path from the starting node to the goal node by backtracking to the G score. So we have step 3. Here, step 3, we have the termination. If the open set becomes the empty and the goal node is not found, there is no path from the starting node to the goal node. So by repeatedly selecting the nodes within the lowest F score for the expansion, the A star algorithm efficiently explores the graph and ultimately find the shortest path to the goal. So for each neighbor of the current node, if the neighbor is already closed list, ignore it already been processed. Calculate a tentative of GNA like G of n for the neighbor's current node of G of n plus the cost move from the current node to the neighbor, like that we want to calculate. So in this neighbor is not open list or the 10 like score is less than the neighbor current g of n. So we want to update the neighbor calculate the neighbor, update the neighbor again, like with the formula of f of n equal to g of n plus h of n, and set the current node as the neighbor parent. If the neighbor is not a open list, and you add it, and it if it is uh, update its position, the periodic which if it is f of n has improved. So here we have the applications of the A-star algorithm. So we have robotics and automation vehicles and game development and GPS navigation systems, logistic and supplement chain management, network routing and traffic management. So here we have the common uses of applications. So video games. From the video games, we can say A-star is an employment to the manage the movements of the non-players characteristics like NPCs, allowing them to navigate the complex trainers complex trainers and respond to the dynamic to the player actions. It also uses the real-time strategy of RTS and the simulations games to enhance the AI decision making. And we have robotics. So in robotics, we can say A-star assists the robots in the navigating through environment by computing the collision-free path, enabling them to move the efficient while avoiding the obstacles. It also helps to automate the vehicle navigations, ensure safe and optimal movements in dynamic environment. So we have a GPS routing system. In third, we are in definition of Geographic Information System, GIS. So A-star supports the terrain navigation and the geo-hospital application by the finding optimal travel paths. It is also used in environmental modeling, and such as a widely spreaded predictions. So, network routing. A-star helps to optimize the data packets routing in computer networks, improving the performance and the efficiency. And GPS and routing planning in the traffic signals. So A-star powered the route planning applications such as the GPS navigation system to the calculate the shortest or fastest route between the locations. It is widely applied in the logistic and the delivering the routing to optimize travel time and the efficiency. So AI-based decision making. So AI is used in many predictions and decision making statements. When we have the multiple statements and the decisions, so it do the majority of voting. It chooses the right priority decision to us. So advantages of A-star algorithm in AI. So we have the optimal search. So in optimal search, we can find AI A-star algorithm ensures to obtain the shortest path between the 2 points following the approachment between the heuristic functions. And we have the versatility. So versatility is nothing but it can be applied in the various domains such as robotics, gaming, logistics, and more. That makes it is a versatile uh, algorithm for the finding the shortest path in the different cases. Heuristic approaches. A-star works on the heuristic approaches for the searching that helps in the exploring the optimal path from the decision nodes. This is significantly reduce the number of the nodes that need to be evaluated right compared to the other uninformed such algorithms. Adaptability. A-star is adaptable and can be modified with the help of different heuristic functions that allows the development to the alter it according to the specific problem in the domain of or requirement. So disadvantages of the A-star algorithm in AI. So we have the disadvantages of memory incentive. In certain scenario, A-star might consume more memory due to the its needs to store uninformed about the explored nodes and paths, especially in the large search space or grid. We have heuristic dependency. So A star is heavily relies on the heuristic functions or guiding its search. So if the heuristic is a poorly chosen or unable to find the right estimated cost, it might not be able to find the optimal path or might takes a longer to calculate does not adopt the dynamic environment. So A-star assumes that a statical environment during the search process. If the environment changes dynamically, the previously calculated path may not become invalid and requires a recomputation of the path. So it has not allowed the efficient with the high cost. So in the scenario where the cost foundation between the nodes in the non-uniform or irregular, A-star may explore the large number of unnecessary nodes before finding the optimal path. which will make unnecessary computations and that until ultimately increase the time of the to calculate the optimal paths. So I hope you guys all are understand about the topic of what is A star algorithm. In next lecture, we discuss about the how the algorithm performs in practically in theoretically again. So I hope you guys all of you understand about this. Thank you.